Okay, so once you've jumped into teaching about histograms, we're going to now jump into looking at understanding what shape of data is and how that can even help us. So we want to figure out, how do we describe that distribution of this quantitative variable we've been looking at? Well, why even teach shape? Okay. Well, it's super important because numbers do not tell the whole story. And there's a great website, a link to this is in the lesson, that you can show the students that numbers just don't tell the whole story. Right here's an example. This is a dinosaur here, but they have all of those 9 graphs that I'm showing you there have that same set of statistics that are shown there, yet they look very different. They tell a different story. And so just because you have the numbers doesn't mean you have the whole story. Well, I put some histograms down at the bottom. You could have the same mean, the same average, and tell a very different story. And in our coaching sessions, talk to teachers about, you could have a C average in your class, and that could mean that every student got a C on the test, or it could mean that the students either half the class had an A and half the class had an F. Very different stories, very different strategies you have to take after the test to review and to reteach things, right? And you would approach things differently. And so it is very important that we also look at shape. What is the shape of how that data came about? Not just numbers. Okay? And so there's 3 different shapes that we look at, and it's really important that we don't just learn technical terms, but we also teach them in context. And here's your 3 shapes. Your data will either be skewed to the right, left, or symmetric. Okay? Skewed to the right is where most of the data is on the left, and then there's just something pulling it to the right, skewing it to the right. And most kids think skewed right means most of the data is on the right. And get that in coach when we're training too. A lot of teachers think skewed right that same way. Skewed right means that there's a tail on the right. And so a great way to remember that is to have them put up their right foot, and they see their little pinky trails off to the right. And so you can see it skewing to the right. Okay. So most of the data points are clumped around what's typical in the data there. And then you have it trailing off. And then there's a real world scenario to talk to students, income, we joke about that, you got your Bill Gates and your Winfrey, Oprah Winfrey's out there going off, but teachers might be in the negative, but nobody's really making negative money, okay? All right, the skewed left is the same thing, but now instead it's trailing off on the left instead, and there's a worksheet we do where they put teeth in, and so most people have a full mouth of teeth, but you might have some that have lost some teeth, or hockey players or whatever that have lost a few, or like my grandparents who had them all pulled out and more dentures, right? Okay, symmetric. There's where you're just equally likely to be above the middle as below the middle. And so things like the restaurant's busy time is like 7 p.m. and then you have some that come before it, some that come after it. But we want to be careful when we teach symmetric that we don't make it seem as if this big graph here is the only way that symmetric is. That's a very common look. The bell shape is that common look for a symmetric. But you have some others that are symmetric. It just means if I folded my graph on itself, basically it would kind of be even. And we're always thinking about, they're not going to be exactly, these are the way these were drawn. They're pretty much, these are about the same, but fairly symmetric, fairly close to folding on each other. And so this is called a bimodal symmetric distribution, and this is a uniform symmetric distribution when all of them are equally likely there going across. Okay? But all 3 of those are examples of symmetric, and so make sure that we use them all. So students are going to then take these shapes that we'll be practicing identifying shapes. They're going to then apply the data cycle to the animals data set and put in a quantitative variable and see what the shape is. Then they're going to go to their own chosen data set and do a histogram there. Then a good discussion needs to be had about how to handle outliers. And should they stay or should they go is the name of the worksheet. Oh, that's should they stay or should they go? Okay. So I just wanted to bring this up for some discussion with us real quickly. This is one of the things that they should be looking at. Because I found as I was working with students, especially in their own data sets, if they find outliers, they say, this is messing my data up. I just want to delete it. That's their first thing. They want to delete. We cannot delete outliers. Really, you shouldn't ever delete them unless you know for certain that it was an error. And here, this is the way they look at these graphs. You see they've got the height of 12-year-olds. Well, obviously, you're not going to have a 6-inch 12-year-old. I've got that circled down there. That's probably an error. But even if you're deleting it, as a responsible data scientist, you should write in your report that you needed to delete that piece of data and say what happened. However, on the right, you can see that you've got a survey and how long did it take you to find your seat at the stadium. And you have one person way out there that took 35 minutes. Now, could it be an error? Maybe. But could it not? Yeah, it may be. Maybe there was a problem, and maybe that's exactly the problem the stadium needs to work out. Maybe they had someone in a wheelchair who couldn't get access to their seats or something that they need to figure out. So we have to be very careful that maybe that's a very important piece of data and we need to be looking at it. So what should we do when students have outliers? I tell the students this. Okay, because we're trying to find out what's typical of our data, and this definitely is altering what's typical. We'll talk about that when we do measures of center. Measures of center, yes, if you have outliers, it's going to skew your mean. And so it's kind of making a little bit of an adjustment there that you don't like of what's typical. So I have the students do an analysis with it and an analysis without it and write up both of them sometimes. That's one way to handle it. Okay. And just note in the report what they did. And they can actually, it's interesting to do an analysis and compare the two. So, but definitely not ignoring it. Okay. One last activity to do in the classroom that is really fun once you have done this is I take a piece of flip paper or spot on a whiteboard, however you want to do it, cut it into 3 horizontal sections. At the top of each page, put the different shapes around the room so that you have symmetric, left skewed, right skewed, however many you need to have enough for your group classes to be in groups of 2 or 3. Okay. As then they start at one of the posters. So if I'm a group, my group starts at symmetric. Okay. Then our first task is to just draw a histogram of that shape. Not to put it in any context at all. Just draw a basic histogram. No words, no nothing on it. Just a plain old histogram. Get a histogram that looks symmetric in shape. Okay. They don't give them a heads up about this, but they're sitting there talking about what a symmetric one would look like, and they get it drawn, okay? And then you tell them to rotate. Now they're going to rotate, and they're going to go to the next chart. They're going to go maybe to skewed left next. And now they're going to look at the skewed left histogram that group had drawn, and they need to write a real-world scenario that would match the graph that was drawn there, the display, and put a scenario to it. It's pretty fun, looks really good, and so everybody gets a chance to take a look at those 2 scenarios. Now, if you plan to teach box plots, save those charts, and I'll talk about that later, but the third section will be that you'll come back to that and they'll rotate again, and they'll go to the third shape that they had not done and put a box plot that matches all of these. But if you don't plan to do box plots, then you can rotate right now and have them go to the next shape and have them write another scenario over there that would go to the next shape. But it's really fun and a great way to summarize what they have just learned.